Okay, today we're going to get into more additional stuff, obviously, on our fuel systems.
Give me a bag.
Real quick. I did on another student. I don't want to do that again because they're going to be coming down here all the time.
Whoa, what is that?
And Mr. Getsky, is there hard fuel too?
Hard fuel?
Says easy fuel, is there hard fuel?
I'm gonna assume no. All right. Yesterday we talked about gas caps.
Give me a bag.
We talked about fuel tanks.
What the hell? Dude, that sounded like you parking your car.
Shh. No, I'm trying to get your attention here. Focus in on me, please. We're taking notes now.
Yeah, that's my notebook in my house.
Don't worry. I got.
We can share. We can share. Me and Angel are sharing. That's what best friends do. We share. Ain't that right, buddy? Sing the song for SpongeBob.
Imagine not having line paper.
I know, right?
Imagine not getting line paper.
You're gonna be writing crooked, that's for sure. There you go.
You never know, it might not be tight enough.
Paper?
You want some line paper? I can lend you one.
Is that my note card size?
Yeah, you will.
You do lines?
Is that my note card?
I do lines. Wow. I love lines.
I don't have any more pencils though.
Is that our new note card size?
Wait, what'd you say?
No.
Can I make my note card bigger?
No, 3x5.
I do lines with that.
This is not 3x5 note card.
I know, what if I make attach things to make it?
No.
I can use a staple. I've got both sides.
You got both sides.
All
Alright, here we go. Yesterday we talked about gas caps. In our fuel tank, we have our fuel filler neck. As we put and store liquid gasoline in our tank, there's a good possibility that there's going to be some vaporization, right? Hey, I take some water, I put it in a tank. At some point in time, some of that water is going to be evaporating. It's just kind of how things work, okay? Unfortunately, unlike water, when fuel vaporizes, it is a pollutant, hydrocarbon. We don't want it to pollute out the environment, so we have to capture that and hold on to it. Yesterday we talked about a couple ways that we can mitigate that. Okay, in terms of the design of the fuel tank with the dome, kind of capture that, and also our charcoal canister, part of our EVAP system, or evaporative emission control. We allow the tank to vent out, but we capture the vaporized hydrocarbons before it exits the fuel tank. Okay, and then eventually we can take those and run that through the engine and burn it instead of releasing it out into the environment. Okay, now because the fuel cap is going to seal off that tank and it is going to prevent those vapors from escaping because it's the highest point, there's a couple ways we can do this. Now obviously the cap, again, tighten that up to a particular torque. Ford actually has what's called an easy fuel. Instead of having a cap that you have to twist on there, it's basically like a little flapper. Okay, so as you put your gas in the vehicle, as you insert this whole entire component is on a hinge. Okay, so this is a hinge, and this is a little door right here that'll open up. Okay, to allow you to fill the gas up. Then as soon as you take this out, this is going to be spring loaded. It's going to come in here and it's going to actually shut this off and seal it with no extra needed input from you as the driver. So it's easy because you just boom in and out and you're good to go. Okay, so it's kind of fun that way. So at some point in time in the future, you might actually come across a vehicle like this. Okay, not every vehicle obviously has this on it because gas caps are cheap. Unfortunately, this particular technology, if you're going to try to fill up your gas tank outside of a gas station, it's very difficult to get the nozzle of a gas can to open this up because it's a pretty strong spring. So you typically are going to have some kind of funnel that's usually in your glove compartment or somewhere on the vehicle that you need to essentially get out to insert it into there to open that flapper up so then you can add fuel manually that way. You know what I mean, Tim?
What? Oh.
Oh.
Yo, Timmy, you got moved.
We had a conversation without having a
All right.
AJ drinks some piss.
Stop. All right. as part of our fuel storage system, right, we're able to store that fuel.
That shit good.
Now we need to figure out a way to transport that fuel up to the front of the engine, right? Which is a little bit easier said than done. Obviously, we have a fuel pump that's going to pump that up, just like our lubrication system with the oil pump or our coolant system with the water pump. And we're going to run through some lines. Now, these lines are connected to various parts of the vehicle. We have to pass through typically a fuel filter. The fun part about these connections is they're not threaded. Okay, they're not like a normal nut and bolt where you're just going to twist it on and it's going to kind of clamp it together and hold it there. The main reason for that is because, again, the fuel lines are pressurized, and if it's pressurized to a certain point, that can actually force the liquid gasoline out through the threads. So it's not a good sealing. So what we end up doing is creating what's called a quick disconnect, in that it's like this plastic insert or metal, right? It goes over the top of it, and it actually clicks over it and holds it and snugs it and seals it off, so that way as gas flows through, no leaks. It's pretty nice. It's also really nice because you don't need to necessarily take a long time to disconnect it with like a screwdriver or a socket. All right. Let's see here. But the only downside to this whole thing is that you need a specific tool in order to do this. And I'll go back to that slide here in a moment, but let me just show you this. So this is called a quick disconnect tool. Its sole purpose in life is to literally disconnect the quick disconnect. So you take this tool, you put it over a line, just like how you see here, and then what ends up happening is you push this into your connector, and there's basically like, if I were to draw kind of the inside of this, there's like two tabs here and here that we push together, which then allows us to pull it apart. Okay? Once you have that disconnected, super easy to take things apart, obviously, put things back together again. Then to reassemble it, you just push it over the top of it, and it clicks on, and it's done. It's sealed.
Wow.
So it's pretty good that way. Okay? Again, let me go back here real fast. So that's how you could get your fuel filter off in like 5 minutes. Again, if you don't have this particular tool though, you ain't gonna get it off. Okay? Usually, what you also want to end up doing is, if you're under the vehicle doing an oil change or around the vehicle, you can do a very quick visual inspection for the fuel lines, because they can corrode and rust and damage and leak over time. So if you notice that there's any kind of corrosion on those lines, or there's any kind of like, it looks like it's damp, like something is liquid, it's obviously going to be something that needs to be addressed, because we don't want fuel leaking out from our tank, because then that's a fire hazard, right? So one of those things. All right, fuel filters, again, more often than not, they are in line with the fuel line, because we have to pass through that as it's making its way up to the engine. We want to try to filter out any kind of debris or particles that could cause damage to our fuel injectors or inside of our combustion chamber. And again, typically these fuel filters are probably replaced.
Aren't those plastic?
100,000 miles. Typically metal, but it's a small little canister. I mean, they're like this big, this around. They're not very large. Okay, depending on the vehicle, I should say. Okay. If your fuel filter is not in line on the fuel line itself, it's going to be in the fuel tank, part of that fuel sending unit. So if I'm going to replace my fuel filter, in that case, I'm literally going to have access to be able to take that whole thing out and put a brand new unit in. You wouldn't necessarily take the fuel filter out of the fuel sending unit and then put that back. It's just an entire replacement. So it's a little bit more costly, a little bit more time intensive, but when you do replace it, new fuel pump, new strainer, the whole 9 yards. So there's that, okay? But again, it's part of a tune-up. If, for whatever reason, you are thinking that your fuel line is being restricted somehow, some way, right? Hey, I'm actually testing the fuel pressure on my fuel rail, and it's not where it needs to be at for the specification for whatever a manufacturer is telling you, we could potentially expect that the fuel filter is starting to get clogged or show its age. More often than not, a replacement of that might restore you back to where it should be at, okay? But again, that's true with any filter, right? Oil filter, a water filter, you wanna make sure that you're changing that out on an interval. But fuel filters, fuel in general is pretty clean to begin with, mostly. So these fuel filters aren't necessarily filtering out a ton of stuff to begin with.
You said 100,000 miles.
Roughly.
Isn't it like 7,000 on average per year?
15,000 per year typically.
Oh,
So maybe once every 10 years.
I was gonna say it's once every like 10 years.
Yeah, it's not much. The fun part is there's probably vehicles on the road, I'll guarantee you, many vehicles on the road that have over 100,000 miles that have never had their fuel filter replaced or even looked at, okay? And again, that's not necessarily a bad thing, it's just by maintaining the simple stuff, it helps prolong the expensive stuff. So if I'm proactively going in and changing my fuel filter out at 100,000 miles, I'm not guaranteeing, but I'm definitely doing what I need to do to make sure that my bills in the future are not as expensive. All right, which of the following are used to stop contaminants from entering parts that could be damaged by foreign matter? Flickers, oh flickers. Oh, that's not. Uh-oh.
Wake up, buddy.
I think it's D.
Yo, it's D. Give me the D.
What did you
That's
say?
what Ryan.
There are a whole lot of dudes in here running.
You thought that
Stop, guys, we don't need those kind of comments. Oh,
Thank
Jimmy looks good. Yeah, I got you.
you.
I think I got everybody that's out. Yeah.
Why is my computer slow as
All right, we got everybody? I think we got everybody.
I will win.
Exciting.
Did we do good?
No.
Damn it.
Only one student got this one right.
Huh? What?
It's crazy.
What? What is that?
No way, everyone.
What? Hold on a second.
Huh? Did I pick the right one?
I think your phone's bugging.
Did we do?
No. Sorry. Why did that do that?
Can we see the answers?
Do we have to redo it?
Yeah, we're gonna redo it.
Oh,
I was on the wrong.
it.
Sorry, I was on the wrong question.
Of course you were.
Which was, I'm like, why is no one getting this one right? Okay, I think I got everybody now. There, that's way better. Way better. Okay, 88% of you guys got that one right now.
Let's go.
Okay, let's share with you guys what you guys chose as the correct answer. Not the right answer.
Let's go.
Oops.
Bro, that knot though was actually kind of fun.
Fuel filters, right?
Hell yeah!
Let's go. Whoa, calm down. Fuel filters.
To me, this is the first one he's gotten.
Gonna be filtering out, obviously, foreign contaminants. All right, give me a second. I gotta get some passes here.
I'm going to guys. Dude, I was in my car yesterday. Some dude's name was like phone number. Did you finish that door latch?
What?
Literally,
Yo, you can hear that?
CDA doors.
Why?
My shit's not on.
Let's see.
It's off.
Can you hear me?
Well, yeah.
She brings her edit.
Stop. Takes her. No, I don't want to hear it. I don't want to hear it.
Yeah, that's why.
Oh yeah, whenever she's on a good day, I'll do it.
But like,
Yeah, the team big ass top. Shit's good.
Oh my God. Sweetie. Okay, so I've been in the business.
Big ass.
Fresh my soccer.
Big ass black headed man. I do.
Apologize for that. Just had to take care of some out of 2 kiddos there. All right. We're going to talk briefly about another distinction in fuel systems. We obviously talked about the return versus returnless. We talked about fuel storage / delivery and fuel injection. Okay, most of the time the last couple of days we've been talking about fuel storage and delivery. Now we're going to start getting into the injection side of stuff. Okay, so there are generally speaking 2 distinct ways to inject fuel into our combustion chamber in an engine. Okay, one we've kind of briefly touched on, multi-port fuel injection. Okay, and now we have gasoline direct injection. Okay, those are 2 terms you need to know and should know.
Can you repeat it?
We already talked about briefly the multi-port fuel injection, multi-port, and gasoline direct injection, GDI. Okay, there are 2 very distinct ways to do this. Now, GDI is starting to see an uptick in terms of its popularity in relationship to directly injecting the fuel into the combustion chamber, as opposed to a multi-port, which is a little bit easier way of doing things, and it's probably more common on most basic vehicles. Okay, now again, I want to make sure that I emphasize this. There is no one that's better than the other. It all depends on what you want as an outcome for your engine. Okay?
Speed.
It also is going to be positives and negatives on both sides. Okay? GDI is not the end all be all. It's not better than multi-port. Multi-port is not better than GDI. Again, it all depends on what you want as an engineer from the manufacturer, from your engine. Okay? If I'm looking at potentially increasing horsepower, right, I'm probably looking on the more GDI side of things.
Explain.
Right? I will explain. I got to teach you what it is first, then you can probably connect those dots. If I'm looking for inexpensive and also cleanliness, I'm probably looking at port fuel, multi-port. Okay. So now, vehicles that are GDI, because we're directly injecting liquid gasoline into the combustion chamber, where the spark plug and the valves and the piston live, okay, we have to make sure that we have a sufficient amount of pressure to be able to inject enough fuel at the amount of time to mix with the air prior to combustion. Okay, so that's why these particular systems need a secondary fuel pump. Not just the fuel pump in the gas tank will be sufficient. We also need to now have a fuel pump that's typically run by the camshaft that's going to increase the fuel pressure significantly to achieve this goal.
15,000 PSI.
Okay. Typically speaking, my multi-port fuel injection running off of the single fuel pump, we're looking at 30 to 50 PSI. Okay, that's still a pretty decent amount. But for direct injection, we need 15 to 2,500 PSI.
Why does that not
1,500,
explode?
2,500.
Cause it's got somewhere to go.
Well,
Right.
yeah, but your tires are like 30.
Yes, but that's the type of pressure that we're injecting it into. Okay,
So that
the
goes
speed
fast.
and the force that we need to inject it to be able to mix with the air for combustion. Okay, it's a significant, dramatic increase. So with those additional parts, GDI is not like cheap, right? Multi-port's cheaper because we can run off of a single fuel pump, amongst other things. Okay. Now, here's a good, I guess we would say, illustration of what the primary difference is between GDI and multi-port. Okay. So in this case, again, since we're talking about GDI, I'll start over here. Here's my spark plug, right? I'm sparking I got my valve here, my intake valve, and I got my exhaust valve. Okay? And then I've got my fuel injector right here. I'm able to spray my gasoline directly into the combustion chamber. So then that way, as as the air is coming into the combustion chamber, right, it's swirling around, and then that liquid gasoline is atomized enough to be able to be turned directly into vapor as the piston is compressing it, and we can burn it, okay? So in terms of efficiency, this has got it, okay? We're literally delivering the fuel source directly where it needs to be at in order to burn it. Okay, so we can control the precision of the amount and all this sort of stuff. Much, much better control. Okay, which is obviously going to give us better efficiency and horsepower and all that sort of stuff. Okay, now a multi-port injection system, instead of having the fuel injector next to the spark plug going into the combustion chamber, it's actually out here on our intake manifold. Okay, so we're literally spraying our gasoline into the intake manifold, so as the air is entering into the combustion chamber, it's mixing with the gas and then going in. Okay? Now, a couple benefits to this particular one is the fact that as this is being sprayed, it's spraying on the back side of our intake valve, so it actually cleans that intake valve. So it doesn't get all the carbon deposits and everything along those lines, which is something absent here. You'll notice on GDI engines, if you take the valves out, the intake valve is much dirtier than on a multi-port. Yeah?
What about meth injection?
Like nitrous?
Yeah, can you explain that?
I'm not going to get into nitrous, but
Not even nitrous. No, can you just draw it up there?
it would be a similar fashion. Okay?
Who?
But nitrous oxide, okay, it's a chemical, right?
That's galaxy gas, by the way.
So typically what ends up happening is as I'm injecting nitrous oxide into the combustion chamber, we have a chemical reaction that splits the nitrogen from the oxygen. Okay? Now nitrogen is a noble gas, it's inert, it's right, it's not going to really chemically react. But by splitting it, now all of a sudden I've made available a whole bunch of oxygen.
Big boom.
And if you've ever noticed that pure oxygen added to a fire, what does it do to the fire? It makes it burn hotter. And if the fire is burning hotter, what's going to happen inside my combustion chamber?
Bigger boom.
Exactly. So I'm going to have more force on my piston. That's what nitrous oxide does. Okay? So the thing with that is, let me just kind of hook this back into what we're talking about. If, let's say, I'm running nitrous oxide, I need to know the amount that I'm injecting into my combustion chamber, because then I need to add a larger amount of fuel,
250 shot.
okay, through my fuel injector. So the computer needs to know all the parameters of how much air, how much nitrous oxide, whatever that may end up being, okay, the RPM of the engine, okay, so then that way I can add the proper amount of fuel, and at the same point in time, I can also change when I spark that spark plug. So there's a lot that goes on. It's not just simply, let's just dump something in there, and it's not going to work.
Yeah, what?
Things need to change, okay?
Ryan didn't hear the part where you had to change, so Ryan's just gonna put some
Right.
in.
No.
Okay, so that's my spiel on nitrous oxide. I'm not going to get into that anymore. All right, getting back into our fuel pump.
Boring.
Okay, the fuel pump is not necessarily very large, right? It's maybe like this long,
That's pretty big.
this around. It's not this massive oil pump or water pump that you would have in your lubrication or water or coolant system. It's literally an electric motor. So we have this thing hooked up, it's submerged in the gasoline, and we're running electrical current through it. Right? So what's the question we should ask ourselves?
Why are we sending electrical current through
How
our
do I get more horsepower?
Why are we sending electrical current through gasoline? Isn't that explosive? Isn't that dangerous? Wouldn't it light on fire?
No.
The answer is you have to understand the properties of liquid gasoline. It doesn't combust, right? The vapor is the only thing that's going to combust. So as long as my electric motor is submerged, I'm fine. We also have to understand too that the gasoline itself is acting as a coolant for that fuel pump. So as that fuel pump is warming up due to the fact that it's doing work, that fuel is essentially helping cool that down.
Is
Is that cooling down or is it warming up the gas?
Well, it's gonna warm up the gas, cause that's gonna absorb some of the energy, but it's gonna keep the fuel pump at a lower temperature. Now, here's something we have to keep in mind. What happens if I'm constantly keeping my gas tank towards empty?
Well, that fuel pump not getting cooled down there, but
It's gonna be in the vapor.
Right? The fuel pump is gonna be more exposed to potentially that vapor. Also, it's gonna take away the fuel pump from staying as cool as it needs to be. So you're more likely to actually overheat your fuel pump. You probably, one or twice, not a big deal, but if it's consistently having that issue, you're gonna burn through a fuel pump much faster than if you were to maintain as full a gas tank as possible, right? So here's my little lecture on you for this. Don't let your tank always go to E and leave it there, right? Don't put $5 in and just kind of top or put a little bit in every once in a while. Fill your tank up,
Well, that'll give you like a gallon and a half.
right? I'm just simply saying like,
I bought 30,000.
that fuel is in there not just to get you to go where you're going, it's also to help lengthen certain components.
To the other pump. That'll get you to the next pump.
All right, again, I just want to emphasize this. Typical multi-port fuel injection, one fuel pump, typically 30 to 50 PSI. GDI, two fuel pumps, one in the tank, one at the engine. We're typically looking at about 1,500 to 2,500 PSI.
Yeah, see, that's not it.
How much is the diesel PSI?
Oh, God.
26,000.
26,000.
That's as much as a water jet cutter. How is that not breaking through the goddamn block?
Because we're vaporizing. But you gotta understand how diesel engines work, right? And we're not gonna get into that.
Can we please?
Here's what I wanna share with you. When you're working with fuel systems, I need to replace my injector, I need to change a fuel pump out, whatever that means, I need to do a fuel filter. You are potentially dealing with fuel pressures that are extraordinarily dangerous to your health. So before even trying to go in and tackle replacing parts or components, it is critical that you are depressurizing the system. Okay, and again, we talked about this, but the simplest and easy way of doing this, whether it's a diesel, a GDI, or a multi-port fuel injection, take the relay for the fuel pump out. Like literally, you're shutting that circuit off. You're gonna try to start the car and run the car. All the fuel that might be pressurized to these levels is gonna get utilized by the engine until there's no more fuel, because the fuel pump can't pump any more out, because we literally disabled it. Okay, once the engine shuts off, you can't restart it, there's no fuel pressure. It's not necessarily ideal, but it's not going to damage it.
Off of one time.
Right, right, it's not something. There are other ways to depressurize it, but that I find is typically the fastest and the most effective. You could theoretically hook up to the fuel rail. There are tools, hook it up, and then you can actually depressurize it that way. The problem is that fuel pump is still energized, and if I'm working on this and someone turns on the car, fuel pump is pumping up stuff. Where if I take that out, depressurize it, you can't even start the car up. Now it's, right?
I mean, you can start it up.
It's like saying, hey, I'm gonna go clean my gun, right? I have no bullet in the chamber, but man, I got my clip in there with 12 rounds, right? I don't even want to deal with that. I'm going to pull the clip out. I'm going to leave it so that way it's as safe as possible. If that analogy makes sense.
That makes sense.
All right, gas engine fuel pressure is typically much higher than a diesel engine.
True. You know? True. I don't know about this one, but if we don't get 100%, we got something wrong, I guess.
I mean, I even gave you a true or false question. This should be, this should be pretty
You got at
good.
least 50-50. Guessing, what if I put up letter
What are you guys talking about? It's D.
If you select C or D, it actually, I think,
That
gives you
shit
a
was
wrong
so
answer.
funny, I almost forgot the left.
I got this, Brad.
Eric, your hand's in front of you.
Yes. Engine.
Wait, what?
I think it's right.
All right. I think we got everybody. All right, we got Jesse.
Did we get it right? Did we get it right?
Oh, hold on a second.
Jesus
If I'm not looking at 100 jet skis,
0%.
93% of you guys got that one correct.
Who is dumber than a box
No, no,
racer?
no, no, no. All right, gas.
Why they me?
Let's go back a slide. Gas engine fuel pressure is what? 50 probably on most cases. What's diesel pressure?
26,000.
26,000, just a little bit more than 50.
Only
So,
like-
is gas engine fuel pressure typically much higher than diesel?
So I was right.
No,
Does
you're not.
does diesel have one?
False.
Does diesel have one or two
Bro, that's
pumps?
what
He said he was right.
It's typically much
I
higher
don't
than
know.
diesel.
I would assume two.
Diesel, we literally just said diesel is 26,000.
It's all good.
Oh, okay.
Okay.
I see now. No, I thought it was
It's all
saying
good.
that diesel was typically much
Oh,
higher.
no, no, no. Gasoline typically much higher.
Yeah, but if I can make.
I wasn't.
Bro, I'm not even interested.
Okay, but think about it, like, you're not gonna show up to your program.
Okay.
Well,
In the
but
event,
they're not gonna pay this right now,
in the event of an accident,
you know?
you need to have some safety precautions in place because if I'm in an accident,
Seatbelt.
there's a very good likelihood that as a driver, I might be knocked unconscious. At that point in time, I don't have the capabilities to be able to turn off my car, right? And to make sure that my fuel pump stops pumping fuel, right? It would be a very horrible scenario where you crashed into a telephone pole out in the middle of nowhere, you're knocked unconscious, that damage to the vehicle actually broke a fuel line, and for whatever reason, the fuel pump is still energized and pumping out fuel from the gas tank. There's a good likelihood that there's probably going to touch something that's hot or warm to ignite that fuel. And all of a sudden, boom, you're starting on fire, you're in the car, you're unconscious,
You're dead.
you're dead, right?
You're gone forever.
So, part of that particular safety that's built in is since we have a computerized system that's monitoring a bunch of different sensors, the computer knows when it's shouldn't be functioning, right? Because it knows when it's in an accident. If it's monitoring the CKP signal and it notices that the CKP signal is not sending a, right? So, hey, wait a second, we're flatlined here. We're going to shut off the fuel pump automatically.
Yeah.
The computer's going to turn that switch off. So that way,
What
fuel is
happens
no
if
longer
the
being sent
crankshaft
up to
is-
the engine. What's that, Ryan?
What happens if like it's fine, like the signal is perfectly fine after a crash?
If the signal's still there, right, then the engine's probably still running.
Yeah.
There's probably other things that it would look to. It's not just the CKP. There's safety sensors and stuff that the airbags use to deploy. If the airbags are deployed, the computer knows that there's an accident.
Computer.
Right, like that's easy.
When you're
Part-
going 100
part
meters,
of-
Shaft position sensor.
Right, but there's sometimes you might
Go
be in an
from 100 to
accident
0 in a second.
where the airbags don't get set off.
170, my
Multi
wheels are
airbags
locked.
is bad.
Right.
Everyone check your airbags.
By the way, if you
My
forgot what
energy
the
is not-
CKP is,
That might be.
CKP is a crankshaft position sensor. It's the same sensor that we are sending data to the computer from the
One piston.
crankshaft for our spark plug, right?
Shaped hole.
So we can use this sensor for multiple different systems, not just ignition. Oh, here's a term that
Holy nerd.
this is 100% new to you guys.
Pulse with modulation.
Pulse width modulation. Okay.
Davi, you know about
Oh, I'm
this?
getting it. I'm understanding actually.
Okay.
I actually gotta write this one down.
Before I get into explaining what pulse width modulation is, please understand that engineers and technicians that deal with automotive stuff will typically name something after its purpose, what it does. Okay? So pulse width modulation. What does modulating mean?
You chose the wrong one to start with, Getski.
No, that's where we need to start. What does modulate mean?
Constant, like.
Not constant.
like
Changing.
Changing, right? I'm modulating, going back and forth, right? Okay. Inappropriate, Ryan. So modulating, going back and forth. Pulse width. That's essentially the time that the fuel pump is on in comparison to it's being off. Okay, so literally what's happening is the fuel pump is being turned on, then it's being turned off. It's being turned on, it's being turned off. It's being modulated by this particular frequency or wavelength. So for instance, if I want my fuel pump to have 100% power, right? What's my pulse width modulation going to be? It's going to be on 100%, right? Constantly. That's 100% power. The problem is, what if I want only 50% power out of my fuel pump? Because I don't need all that fuel, right? Well, how do we get 50%? 50% of the time it's on, 50% of the time it's off. 50% of the time it's on, 50%, we're modulating, it's on and off, so that way we only get 50% of the pressure.
I wasn't saying you were gapping, I was saying that was it turning on and off, by the way.
Yes, that's exactly what would be happening. And again, let's say I want an 80% right out of my fuel pump. I'm on 80% of the time, off 20% of the time. I can modulate. The computer is in control of that. So again, the computer is understanding this is how much fuel I need, right, at this given moment. I have to maintain a 30 to 50 psi. In order to do that, yeah, it's no big deal. Okay, in order to maintain that psi, I got to modulate. The fuel pump needs to be at 77%. The computer is going to then turn it on and off based off that, and it can change it at any given point in time to increase or decrease that. So it's just kind of since it's an electronic motor, we're kind of getting the electronic side of things, but that's how these systems work, okay? Which is kind of fun. Okay, especially with the returnless system, because again, a returnless system, we don't return any fuel back to the tank, so we have to be very specific about how much we send forward, because all of it has to be consumed. Where a return system, I can just have my pump all the time, and if it's too much, pressure relief valve opens up and just sends the extra back, right? So it's not as sophisticated as a returnless system. All right, the PCM. What's the PCM?
Position. Hold on.
It's an M at the end, which means it's a module. What's a module?
I got nothing.
Control module, I don't know.
It's a control module.
Position control.
Oh, no.
Pump.
Powertrain
Power.
control module.
Nerd.
Power turning?
It's literally the computer that's in
Imagine if
control
PTC
of the engine or the engine systems. Hey, how much? The powertrain control module is going to say this is how much fuel we need. This is when the spark needs to be happening. This is the position of the crankshaft is currently in, right? It's taking all this information from various sensors and then sending out what it needs to happen. Okay, so the computer and the fuel pump relay are all part of the power supply circuit on many of the vehicles.
When I hit the gas.
Okay. And again, this right here is a wiring diagram. I'm not going to get into that stuff at Auto 1 level. This is more on Auto 2 stuff. But the battery is going to power our electrical stuff, and we have electrical circuitry here to eventually get our energy to our fuel pump to be able to move that fuel forward. Okay? This is very much unlike an oil pump or a water pump. An oil pump and a water pump are typically powered by the crankshaft, either through a belt or literally directly hooked up through a gear system. So the more that the crankshaft turns, the more the water pump or the oil pump turns. A fuel pump, because it's all the way in the back of our car in the fuel tank, I can't have that supplied by the crankshaft of the engine. You know what I mean, Donovan Gerlach?
Yeah.
What?
That's why we have to have an electric motor controlling this, not the crankshaft. Okay? Because the fuel pump is in the back of the car, in the tank, where the oil pump and the water pump are up in the engine. So we can actually utilize the engine to power those. How we doing? Pretty good. All right. We'll end here today. Fuel systems also have a rollover valve and possibly an inertial switch to shut off the fuel pump in case of a vehicle collision or rollover. We already talked about that.
Can't get more like inertia.
Yeah. Listen.
I know what inertia is. I just
Time out.
I wanna talk to you
Let
about
me,
physics.
because we're not gonna talk about this at all for the rest of the school year. Let me talk to you about how this switch works, because it's actually pretty ingenious. Ingenious, yes. Pretty smart. The person who thought of this was smart. Okay. Typically speaking, now this is an older system. You've got a ball right here. That ball is sitting, and it's basically being captured. Sit down. If I'm in an accident, let's say I'm going 70 miles an hour and I hit a telephone pole. Obviously that's very bad. The problem is deaccelerating from 70 to 0 in a very short period of time has a lot of inertia, right? For every object in motion and wants to stay in motion, that ball is traveling 70 miles an hour. If I slam into a wall or a telephone pole, that ball is going to keep traveling forward. It can no longer be held in place. It literally slams forward, and as it slams forward, it essentially pushes a button, which then that signal is then sent back to the computer, and the computer says, my inertia switch just turned on, therefore I must be in an accident. Deploy the airbags, shut the fuel pump off.
Does that mean if I hit the brakes hard enough, I can set up?
I was gonna say that's smart, but if you.
It's designed not to. However, in the past, because we don't use these types anymore, you could be driving down a road with a big pothole, and people have hit the pothole hard enough, it set their airbags off because of this.
Oh, so that's.
No, it's not. So there are other technologies in place that are a little bit more better at that. Anyways.
Right, so what if,